Go outside tonight and look up at the moon. You'll see the same face people saw 1,000 years ago. The same craters, the same dark patches, the same familiar man in the moon. Now here's the strange part. In all of human history, no one standing on Earth has ever seen the other side. The moon keeps one face turned toward us and hides the other completely. It has been doing this for billions of years. So what's back there? And why does the moon never turn around? The obvious answer is that the moon simply doesn't spin. If it were frozen in place, of course we'd only ever see one side. But that answer is completely wrong. The moon does rotate. It turns on its axis exactly once every 27.3 days. And that's the very same amount of time it takes to travel once around the Earth. Its spin and its orbit are locked in perfect step. Astronomers call this synchronous rotation. If the moon suddenly stopped spinning tomorrow, we would actually get to see every side of it over the course of a month. But it wasn't always like this. Rewind about 4.5 billion years to just after the moon formed from a colossal impact with the young Earth. Back then it was a glowing ball of half-molten rock, and it was spinning fast, really fast. If you had been standing on Earth, you would have watched the moon's surface wheel past overhead, showing you a brand new face every few hours. The calm, still moon we know today is nothing like the moon that was born. So what slowed it down? Gravity did. The Earth doesn't pull on the moon evenly. The near side is closer, so it gets tugged a little harder than the far side. That difference stretches the whole moon, ever so slightly, into the shape of an egg. There's a bulge on the side facing Earth and another bulge on the side facing away. The solid rock of the moon is literally deformed by the Earth's pull, and that bulge is about to become a break. Here's the clever part, and nothing planned it. Because the young moon was spinning quickly, it kept carrying that bulge slightly ahead of the line pointing straight at Earth. And the Earth's gravity kept pulling that bulge back. That constant backward tug acted like a hand dragging on a spinning wheel. It fought the rotation, bleeding energy away as heat, and slowing the spin a tiny bit with every single turn. There was no plan and no design, just a bulge being pulled over and over for millions of years. And then something quietly remarkable happens. As the spin slows, it eventually matches the orbit, one rotation for every trip around the Earth. At that exact moment, the bulge stops running ahead. It settles into place, pointing straight at us, and the backward tug fades to nothing. With no force left to slow it down, the moon simply stays there, locked. This happened early in the moon's life, and the same near side has faced us ever since, frozen, mid-turn, forever. Except it isn't perfectly frozen. Watch the moon closely over a month, and it seems to slowly nod and rock, very gently, back and forth. Its orbit is a slightly stretched circle, and its axis is a little bit tilted. So from Earth, the moon appears to wobble. Astronomers call this libration. And that gentle wobble lets us peek around the edges. Over time, we can actually see about 59% of the moon's surface, a little more than half, but the rest stays hidden. So for almost all of human history, that hidden side was a complete mystery. Nobody knew what was there. That finally changed in October of 1959, when a Soviet probe called Luna 3 swung around behind the moon and sent back the first grainy photograph of the far side, and it looked like a different world. The near side is covered in those dark plains we know so well. The far side has almost none of them. It's a pale, rugged, heavily battered landscape of craters over a thicker crust. The two halves of the moon barely look related. And here's the thing, the moon isn't special. Tidal locking is one of the most common relationships in the entire solar system. In fact, every major moon large enough to be round keeps one face toward its planet, exactly like ours does. Jupiter's giant moons do it, Saturn's moons do it, and Pluto and its moon Charon have taken it to the extreme. They're locked to each other, each showing the other just one face, caught in a slow and eternal stare. So the moon isn't standing still at all. It's frozen mid-spin, held there by a bulge and a billion years of gentle dragging. And that very same force is still quietly at work today, slowly pushing the moon farther away from us. If this changed the way you see the moon, subscribe to Curiosity Verified. Then watch the linked video on how the moon is slowly escaping the Earth, and drop a comment telling us what we should explore next.